All right, so I am looking at my final. I'm making pattern number I. That's this lovely pattern. The goal of this project really is to make this beautiful quilted pattern. So you're going to take your pattern you're given, figure out how to break it down into individual repeatable units, and then alternate the colors like a chessboard as your final pattern. So one unit can be like this or this. That will then be repeated. So for me, I started out with an approach problem. What is my simplest unit? How do I create code that's both readable and makes sense for how it's replicated? So how do I make the movement of the turtle between each part of the code the most efficient? So I could have picked this square to start with, or I could pick a triangle, or I could think about it in terms of this shape, the house shape, and then moving that shape around the edge of the square. What I thought of when I kind of dreamed up what would be the easiest way to replicate it is I first thought this like flower shape, but then I had to figure out how to then also make sure I got a square over here and how I would do this base unit. What it came down to is that this shape was the simplest, the one I'm boxing out right here. And the reason is that I have a square, another square, an internal square, and all the corners are squares. You'll see that right here. So the only shape that is ever filled in this pattern is just one simple square. And that's great. It makes it really easy to move through the tile if all I'm doing is telling a turtle to move somewhere, draw a square, and then move somewhere else. This is the setup of our turtle and our screen, and this is the basis of all our code. So all of our code makes sure to toggle color, right? Every fill should be there from the beginning. We have our basic draw a square code. I keep the pen down and up, or I pull the pen down for the fill because you end up with a much more handmade looking aesthetic at the end. If I just kept the pen up for the entire process, you would find that you would have a lot more crisper looking squares. So that I put a comment in the code in case that wants to be changed. Is there anything else here? Oh, length. Length is the basis of everything that's going to be done. So all of the following code is going to be based on our square center length. And there's one square that we'll use to base all of the scalable units off of. So again, when executing this code, we get this simple, beautiful square. So let's look at how this length approximates in other parts of the code. So again, this is our base length. And we want to make sure that all squares, so this square, that square, this longer square here, is all going to be scaled based on this length. And again, we're just repeating squares all over this code. That's it. And that solves our pattern. Oh, and you can also see that with the pen down, you have a little bit of overlap, which is, I think, really lovely. With the pen up, you'd have like crisp, perfect edges. Okay, so let's look at this unit, this length here that we're basing everything off of to make our star. So now here we can toggle two colors. So our first bit of code, the first movement of the turtle is drawing this base green square, and then it's here. And then it's actually going to move 1/4 of the length forward, which we can see that's approximately 1/4, and it is. Then it's going to turn right, and then it's going to move this square diagonal length. Now, how did we get that square diagonal? Well, if we look back to this original code, this length right here is the diagonal for 1 unit square. So again, if this is 1/4, right, and we can see it is of the length, then its diagonal, which we solve using geometry, is that length. And then that means that this square, its side length is 3 times that diagonal. And that's what we write into the code. So it's going to move forward that diagonal length, and then it's going to draw a square with the scaled, appropriately scaled length, and then we're done. So at the end, it should return right here. And you can see our test code, and then you can see the scaling that we have in there to help us solve it. Corner squares. Corner squares are great in that they are just squares. The only thing we need to take into account is that we leave the space in that center. So this is, again, our base length for everything. And we find that the quarter squares are 1/4 of the length of our base square. And so we set that up immediately. And then the way the code works is that it starts here in the corner. It moves forward 5 length squares. So if this is 4 times 1/4 of a length, this is 1 length, of course. So we're moving 1/4 and then 4/4. So we get right here. Then we're going to draw our square, right? And then we're going to move forward 1 length and we're going to turn right. So now we're set up this way and we can repeat the pattern. So it starts 1 square, 2 square, 3 square, 4 square, and ends here. This is our test code. Now you can see with our variable that we have several colors we're toggling, right? That's it. But the only scalable feature still is our length. We want to make sure that everything is always based off of this length, and it is. So now that we have our 4 elements, our star, our corner squares, and then our middle square, all this parts is, all these movements are just setting up for our next little bit of code. Sorry, I'm checking time right now. Okay. How does this start? Well, we're always going to start in this corner. Okay. So it makes sense to first draw the star. So the star is drawn, and then it moves here, here, draws the next one. So we're ending right here for our star. Okay. Then look at this code. We're going to turn right 45 degrees. We're going to move forward 3/4 length, or 3/4 of a length. So again, remember 1 unit is this. So we're moving forward 3/4. That would bring us here, and we're going to look left 90. And then we're going to draw our corner squares. So again, that'll bring us to this quarter, 1, 2, 3, 4. So we'll end right here. And why that's great is that that sets us up for this little square. So this is now getting to the little square. We're right here. Are we? We are. Sorry, we are right here facing this way. Sorry. At the end of the corners, right, we go left 90. So we're facing this way. So at the end, we're facing this way. We're going to go forward half of our length. So that'll bring us to right here, right? 2 1/4 unit squares. We're going to go right 90, and then we're going to back up 1 full length. And then from here, we can draw our little square, which is simply half. Side length is just half our green square base length. Okay, so that's done. Now that we're here, we want to set up for our next square. So our next square should end up in this bottom corner. So we go forward 5 times 1/4 length. So that brings us here. We go right 90, and then we go forward 1/4 length, and then left 90, and we are set up for our next square. So this is our test. This is an incredible base unit, and from here, we're done drawing squares. All we are doing now is moving from unit to unit to unit, right? 1 tile's done, we move to the next tile, but that's already set up for us. So now we're just toggling how we move from different rows or different columns. Okay? So this will be our end impact. From this core unit, right? From here, we can then move to here, which we can then move to there, which we can then move to there, and then here. And then our next one we'll see will move all the way back and then down. One thing I want to point out is that one full tile, do you see that? One full tile is 1.5 of the length of our green square. Or another way of saying it, from here to here is 1.5, or here to here is 1.5 of our base unit. And that's how we'll move. That's how we'll move from row to row based on the number of squares, or from column to column based on the number of squares. So now we're making a row of tiles, and I need to speed up a little bit here because we are almost out of time. So for our end tiles is going to be the number of tiles in a particular row, and sub-rows is going to be the number of rows that it repeats for. So for I in range sub-rows, how many rows to repeat? For I in range tiles, how many tiles to put in a particular row? Draw a tile. So it's going to do that end tiles number of times. And then once it gets to the end of the row, right, we're set up for our next square. We're going to go, right, this is 1.5 units. So 1.5 times the number of tiles there were back. So that'll bring us here, right, 90. And then we're going to go forward 1.5, right, because this is 1.5 units of our base length, and then left 90, and we're set up for our next row. Okay, this is our final repeated pattern, and it is the grossest code to look at so far, but you have to understand that it's just about how to best repeat a pattern. Okay, we have 2 minutes left. So the basis of this pattern is that you're going to draw this core unit, and then you're going to move here, you're going to switch the colors, and because after the core unit's drawn, it sets you up for the next row, there's not even any code here that describes the movement. You are already perfectly set up. So it's going to do this tile, and then move automatically here, and then draw this tile, right? And then move automatically here, and then this last group of tiles. So the only set of movements that we need to code in is that when it's at the bottom of the column, that it comes all the way back up and goes over. And again, that's all going to be scaled off this 1.5 unit base, okay? The total number of columns will tell us how many times to repeat this, okay? And then if the column is odd, so if we are in an odd number for I, then we're going to set the colors here to start with this basis of color. If it's even, then we have another basis of color to start with. And then the row, like what row we're in, will also switch the color. And you'll see that here in the code. Sorry, I'm just watching the time because we are so close to out. Okay, I have 30 seconds left. So it's going to go through this first line of code. It's going to be odd. And then it's going to repeat the tile in this with these colors, and then it's going to flip it for the even number rows. And then it's going to reset, as we talked about before. So it's going to move up rows times total number of sub-rows times 1/2 length. That's just how many times it needs to move up that 1/2 length. And then it's going to move forward the total number of tiles times the 1/2 length. And you can see that. So if there's 2 tiles times 1/2 length, there, right? And then it can reset for the next column. And then it's just going to be the opposite. So now, if you look at the code here, okay, I think I am now out of time. Oh, I'm not. Ooh, I have 50 seconds left, sorry. Okay, so now if you look here, the color for the odd number rows matches the even number rows here. And the color for the even number rows matches the odd number rows here. And it's the same setup each time for moving from column to column. This is our test. This is our final result. That's it. Thanks so much.